Dr. Jerry Decker. He is currently the Warnock Chair in Animal Genomics and an Associate Professor at the University of Missouri Division of Animal Science, Genetics Area Program, and Institute for Data Science and Informatics. Dr. Decker received his bachelor's from New Mexico State, where he majored in animal science with a minor in biology. He earned his PhD at the University of Missouri in genetics with a PhD minor in statistics. Jerry grew up on a small farm in northwest New Mexico, where his family raised registered cattle. He now owns a farm in mid-Missouri to teach his kids the value of hard work and to pass on the legacy of agriculture. His research focuses on understanding the history of cattle breeds, improving the accuracy and breadth of genomic tests, and creating genomic tools to match cattle to their environment and management, which matches the topic of his talk for us today. So everyone, please help me welcome Dr. Decker.
Wrong slide there. Bob, it's the wrong slide there. There we go. All right. First thing that I wanted to do this morning is I wanted to honor and mention Milt Thomas. Very sad to hear his passing. I worked in Milt's lab as an undergrad, and I am where I am today because Milt was kind enough to point me in the right direction. I'll really miss his honoring smile and just really appreciate the effect he had on my career and the industry as a whole. Okay, so the thesis, the main point that I want to communicate to you all today is the way that we match cattle genetics to the environment is by measuring and predicting the correct traits that are directly connected to the biology of environmental stress, okay? So first of all, is matching cattle genetics to the environment actually a worthwhile goal? Is it even worth your 30 minutes to discuss this topic today? Fescue toxicosis, for those of you who are aware, for those of you who aren't aware, talk to someone who deals with fescue toxicosis. Fescue toxicosis costs the beef industry approximately $1 billion a year. On top of that, we have all of the stresses of heat, altitude, cold, etc. So in terms of losses due to this environmental stress, it has a tremendous economic impact. If we go back to the 1960s, there was a very interesting project where they had developed a line of Hereford cows in Florida at the Brooksfield station. And of course, they had the famous lines of Hereford cows in Montana. They did a swap of genetics. And they took cattle from Montana, moved them to Florida. They took cattle from Florida, moved them to Montana. And they compared those to the cattle that stayed there. In one of those papers, they looked at pregnancy rates, and you can see that the Montana cattle in Florida had a 55% pregnancy rate, substantially lower than all of the other subgroups. Okay, so this environmental stress is biologically real, and they put out paper after paper after paper. But then the 1980s came along, and it was like all of that research disappeared. As an industry, I would say in some regards, we just chose to kind of ignore G by E. Now, our plant breeder friends, they continue to be obsessed with G by E, by phenotype by environment interactions. Today, I'm going to give you very brief snippets of 3 grants that I've been fortunate to receive from the USDA. All of these are to help beef producers across the United States be more efficient in their cattle production and try to meet these challenges of environmental stress. In our first grant that was funded, we did a lot of work in terms of genotype by environment interactions, looking at associations with traits. Troy also led some work looking for signatures of selection for environmental traits. And if we look at the genes that get tagged in those studies, these same things came up time and time again, regardless of the trait we were looking at, regardless of the population we were looking at, regardless of the selection scan method. We always saw blood vessel constriction and dilation. Obviously, that plays into fescue toxicosis, that plays into altitude stress, also plays into tolerance to heat and cold. Metabolism comes up time and time again, and things related to immunity. Now, kind of the final piece of Troy's second paper from his PhD is we looked at allele frequency changes across the entire populations. But then we went and did a second step where we looked at allele frequency changes in specific regions of the United States. And we found a handful of loci that were significantly changing in frequency in one region, but weren't necessarily changing in frequency in other regions. And what we hope to find in this analysis is selection for this environmental adaptation. But what we saw in every case is that these allele frequencies were always converging to the breed average. And so what we interpreted from this is that we're actually losing in a local adaptation. We're losing the genetics that potentially match the cattle's genetics to the environment. Now, this is no fault of farmers and ranchers, because they simply, we haven't created tools to allow them to do that, okay? And so because of this lack of tools, we're likely losing that environmental adaptation. So how do we actually do it? How do we course correct? How do we actually begin to help farmers and ranchers match the cow's genetics to the environment? The low-tech way right now is you simply, those commercial breeders, those seed stock breeders, they simply purchase cattle from the similar environment and similar management. We can mask a lot of environmental stress simply by managing those cattle more intensely, more supplemental feed, etc. So the low-tech solution is to purchase genetics, cattle from the same region, same management. Which traits tend to suffer the quickest under environmental stress? Some of those that we've already talked about a little bit would be reproduction and body condition or metabolism. Okay, when those animals are stressed, you end up with more open females, and the females who do get pregnant tend to have poor body condition because they're struggling, they're stressed. Luckily, we do have EPDs for this. We have hyperpregnancy, stability in some regards is a reproduction EPD, but probably not as tightly connected with reproduction as maybe we would want it to be. And then body condition score, you know, Mike McNeil did some nice work as part of that first USDA project that showed that fat thickness was a very strong predictor of sustained cow fertility. Mature cow weight, we've done a lot to bend at the beginning of the growth curve. I would still argue we could do a lot in terms of bending the end of the growth curve. A lot of times when people think about smaller mature cow sizes, they just suck all the growth out of it. They find a frame score 4 and they don't worry about any growth. I would argue with the modern tools that we have, we can do more to bend the beginning of that growth curve, and then the end of that growth curve. And then feed intake, obviously, one of the things of fescue toxicity is it reduces the appetite of the animal. Heat stress reduces the appetite of the animal. One of the things that I'll also say is and I couldn't give this talk with Troy here and Bob here without mentioning this, one of the easy solutions to environmental stress is simply to crossbreed. I remember a conversation I had with Dave Nichols at a BIF several years ago, and he talked about how a young guy could go out and get himself a set of tiger stripe females, and those females would last him the rest of his career. So, are there ways that we can do high-tech and directly select for environmental adaptability? And in my hubris and naivete, I thought we could do this very simply by creating an animal model where we had region-specific EVs. And so what we were thinking here was eco-region-specific genomic predictions. And the spoiler alert for this part of the talk is it simply didn't work very well. So this was some work done by a former grad student of mine, Sarah Nielsen. And what she saw is the amount of variance that got attributed to the G/E effect was really dependent on how aggressively we modeled the contemporary group effects. And so that G/E effect could be anywhere from 3% of the variance to 33% of the variance, and really dependent on that effect. One of the things that I think comes from this is it really ties into sustainability. So there's going to be farmers and ranchers as we move towards more sustainability, as we push for more efficiency in the beef industry, they're going to work to decrease inputs. And one of the questions that I got from this research was, do we have the genetics and do we have the genetic tools to identify those cattle who are going to work under fewer inputs? But the bigger take home from this is that the management and environment are basically all muddied up and tangled together. And the statistical word we would use for that is confounded. So I mentioned earlier, our plant breeding friends really are fascinated with these G/E effects, and they do a tremendous job of identifying specific lines for specific environments. They actually select the lines as well as possible to work in a specific environment. Part of that is with plant genetics, you can replicate those identical genetics in multiple different environments. So every color of corn on this plot is a different line, a different genotype of those corn. And so those are all replicated across the environment, allows us to nicely piece apart the genotype by environment interactions. In beef cattle, each animal is a brand new constellation of genetic effects, something we've never seen before, and unless we clone the animal, something we'll never see again. And so this data structure does not work to look at genotype by environment effects. However, if we go back to the future, the sire genotypes are replicated in lots of different environments. And so I just recently hired a senior research associate, and he's going to be working on making these sire models or perhaps some random regression models work, and to really try to dig into this genotype by environment genomic prediction for our basic growth traits. What has been extremely successful in this space of creating tools for environmental adaptation is the new traits that we've seen come online. So the first of these that was a success, and this was led work both by Colorado State and by Angus, is pulmonary arterial pressure pressure. It is a measure of those animals' blood pressure in a specific part of their circulatory system, and it's a great measure of whether or not those animals are going to fail at altitude. So we've given those breeders a tool at altitude to find the right genetics for their environment. A trait that I've been involved heavily in is hair shedding, and this is on the BIF wiki page. It's described. I've been tremendously appreciative of the industry acceptance of hair shedding. You know, I was scrolling on Facebook one day, and here I see one of the AI studs talking about their bulls who are really performing well for hair shedding. And so it's been a tremendous project to just work closely with about 70 some herds across the United States. Some of my best friends in the beef industry are those herds that participated in the project. Angus Genetics again has led the way here. This tends to become a theme in our industry and maybe a challenge for some of the other breeds to be a little more forward thinking and progressive. Angus released their research EPD in February of 2020, and then they released a production published on the registration page in May of 2022. Not to steal Jamie's thunder, we'll have a 45-minute presentation this afternoon discussing hair shedding. And so we're not going to only talk about some of the nuts and bolts, but we're going to talk about practical uses of hair shedding in your operation. If you're here in the Southeast, or if you sell genetics in the Southeast, I encourage you to come. So this is results from some of Harley Durbin's work. So the heritability for hair shedding kind of ranges from 0.32 to 0.4-ish range. So it's a moderately heritable trait. The repeatability tends to be slightly above the heritability. And so each record that we get on an animal gives us a more clear picture of their genetic potential. With fairly small sample sizes, we get strong model accuracies for hair shedding. Part of that is due to the repeated nature of the scores, and part of that is due to the heritability trait. But even with, 1,800 Brangus, we can get model accuracies of 0.52. With the data set that is publicly available, where we have 36,000 scores, we get prediction accuracies of 0.66. If you think back to the multi-step genomic prediction days, most of the traits that were included in our evaluations as part of that multi-step had accuracies in that 0.6 to 0.7 range. So basically, with hair shedding, with about 38,000 scores, we have probably nearly asymptoted the accuracy that we get. It's a publicly available data set. Happy to share with anyone, any of the genetic service providers. The other nice thing is the statistical term is dispersion. What the cowboy phrase here is we want to see a 1 unit increase in the trait. When we see a 1 unit increase in the EPD, we see that for hair shedding. So it is accurately describing the variation in the trait. So anyone who's a reporter, quote me on this part. Hair shedding is an economically relevant trait. Anyone who wants to disagree with me on this, any of you northern guys, you're going to come to my house in the end of June. You're going to wear your favorite winter coat, and I'm going to wear a nice, thin, button-up shirt. And we're going to go fix fence, and we're going to see who handles it better. And I'll do you one better. 2 weeks later, I'll come to your place. You, again, get to wear the coat, and I get to wear something light and easy, and we will again see who handles the stress better. Hair shedding is an economically relevant trait. It directly measures that animal's ability to deal with stress. None of us as humans would want to wear our winter coat in the middle of summer. We have cows who have the genetic predisposition to retain that winter hair late into the summer. The other thing that hair shedding does is it measures the animal's ability to sense and respond to the environment. I think most people would be completely comfortable calling something that measures the ability to sense and respond to the environment adaptability. If you are going to tout adaptability as a strength of your breed, as a strength of your herd, and you're not measuring it and you're not predicting it, you're just telling us stories. If you're going to promote something as a strength of your breed, you better be measuring it, you better be predicting it. I will get off my soapbox. Michael McNeil, back in 2015, I believe this was in one of the breakout sessions, gave a talk about how efficiency, and in typical Mike fashion, he described all of the complexity of and all of the things that go into the numerator, all of the things that go into the denominator. The take home for you all today is cow efficiency, which cow adaptability, cow genetics to the environment is part of that, is complex. However, hair shedding gives us a tool to start to peer into that complexity of cow efficiency. Hair shedding affects maternal growth, which we as a beef industry have chosen to give in the weird term of milk, because we never measure the milk on a beef cow. It's really maternal growth, reproduction, and importantly, animal welfare. As we think about our license to produce beef in a way that society is comfortable with, hair shedding is directly measuring the welfare of those animals. Okay, so now let's shift gears and talk about two other grants that I have in my group. So circling back, what traits suffer most quickly under environmental stress? Reproduction and body conditions for metabolism. If we think for a minute about which EPDs we've had success in changing as an industry. We've done a lot to change growth traits and calving. We've done a lot to change carcass traits. When we create predictions for those traits, we measure traits that have high information. They're quantitatively measured and they have variation within contemporary traits. We also fit multi-trait models. We fit birth weight, weaning weight, yearling weight together in a model. We fit carcass weight, marbling, ribeye area together in a model. Then we switch to reproduction traits and we put one trait by its lonesome in a single trait model. And even worse than that, we're not measuring the trait quantitatively, we're measuring it in a binary success-failure fashion. So when we try to create EPDs for reproduction traits, we've not applied many of the lessons that we've learned in other traits. So in my group, we have funding to look at heifer fertility and puberty. One of the things that we've done in that grant is looked at a trait that you can call whatever you want. We call it days open. It's how many days of the breeding season did it take for that heifer to conceive? And if she didn't conceive, we give her the maximum length of the breeding season. One of the things that we have to do to actually predict this trait is we have to record when our breeding season starts and when our breeding season ends, okay? Red Angus Association does a great job of doing this. These days open is again an economically relevant trait. First of all, fertility has a tremendous impact on our bottom line. We all understand the costs associated with heifer development, but there's also an added value of the older calves that come from those earlier conceiving cattle. And in the feeder forum last night, we talked about the value of a very tight calving window and the uniformity that brings to a calf crop when we're marketing it. So we looked at data from 18,000 red Angus heifers, 4,000 of them were genotyped. We went and grabbed the 14,000 of their contemporaries who were not genotyped. Simply by switching from a binary yes or no, did this heifer get pregnant, to which day of the breeding season did she get pregnant, the model accuracy went from 0.25 to 0.33. Now, I will note that this is not the accuracy of the National Cattle Evaluation. This is the accuracy of our very small research data set. But if you look at the BIF accuracy, so the accuracies that we predict for each of those individual heifers, the BIF accuracies doubled. So all we did in this data is we took a yes or no heifer pregnancy and moved it to a quantitative measure of when that heifer got pregnant, and we get much more accurate predictions. So I think this is a tremendous opportunity for us as a beef industry to do a much better job of identifying those genetic differences for fertility traits. Want to talk to you for a minute about biological rules and laws, okay? Bergmann's rule. Bergmann's rule is an observation that as we move away from the equator, animals tend to get larger. Now, there's competing explanations for this rule. Do they get larger simply because of physics, due to thermodynamics? A larger object has a smaller surface area to volume ratio, and so it retains the heat easier, okay? The other explanation is nutrient use. As we move away from the equator, we get these big seasonal pulses of primary plant productivity. And there's some thinking that those animals that are larger do a better job of utilizing that primary plant productivity and storing it for later use in the winter. So, is there an advantage to lower surface area to volume ratio in colder climates for our cattle? And is there an advantage to higher surface area to volume ratio at lower latitudes where it's harder? Joe would probably agree with this. We put those eared cattle, they have more surface area. The other is the surface law. This is research that again goes way back into the day to the 1880s, the 1840s, 1850s, where they were measuring the surface area of animals. And they were comparing that to the animal's metabolic rate. And from a little tiny mouse to a huge elephant, there was a direct relationship between surface area and metabolic rate. Now, you can imagine, Sam Brody, a famous University of Missouri researcher, had all of these devices that he was trying to measure surface area. Rollers around the cattle, pieces of lemon. It's really hard to do. So why do we measure weight? Why do we measure body weights? It's simply a very poor proxy for surface area. And it actually does a pretty poor job of predicting that animal's metabolic rate, okay? So again, how does animal shape affect its efficiency in terms of feed intake and metabolism? What would you do if you could accurately measure the surface area and volume of your cattle? If you could have a direct prediction of their metabolic rate due to this 3D image, would you feed one group of cattle differently than a different group of cattle? Would you, based on their metabolism, would you market those animals differently? For those of you who are breeders, would you select your animals differently? Because now we're giving you a very accurate measure of that animal's metabolic needs. We have a technology at the University of Missouri where we have a provisional patent. We're working currently on a full patent. There's any of you in the audience who would be interested in talking about licensing this, come see me. I am an academic. I want to give talks like this. I'm not an entrepreneur, so we're looking for partners for that technology. What that 3D imaging does is allows us, instead of measuring the messy trait of body weight, we get to the right trait that the founders of animal metabolism from the 1880s, the 1850s were saying that we should have measured. Now we're measuring the biologically important thing. Now, instead of messy, noisy measures of fertility, no measures of fertility, we can create more information-rich measures of fertility. And there's lots of other examples, pap, hair shedding, etc., to help our industry create the right cattle to match the environment. We have to measure the right traits, and we have to measure the traits that are directly connected to biology. That's how we solve this problem. For U.S. seed stock producers, it may mean that we add a handful of additional traits that you need to measure, but that's a responsibility you have to provide customer service to your clients. And if you're one of those northern guys, if you're selling genetics across the United States, you still need to provide that customer service to all of your customers. With that, I really acknowledge the USDA funding, the support of the various breed associations that have worked with us, and all of the graduate students and collaborators that have worked with this. And one last plug is we're currently recruiting a livestock judging coach and instructor. If you know someone who would love to join our exciting team at the University of Missouri, have them come talk. Looking forward to the questions in the Q&A section.